Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper question for AP Physics 1. In this series, we will only focus on multiple choice questions, and after this series, we will focus on FRQs as well. We will discuss these questions in detail so you can improve your conceptual understanding of AP Physics topics, and also you can have better understanding of these questions. And also, if you have any questions from any past papers, you can leave your questions in comments, and I will try to answer as soon as possible. Let's study together, let's improve together. AP Physics 1 exam consists of two sections. Section 1 has only multiple choice questions and section 2 has only FRQs. Section 1, total time for section 1 is 90 minutes and total number of questions in this section are 50, and this is 50% of total scores. And this section is also divided into two parts. For question 1 to question 45, you have to choose only one single best answer, and for questions from 46 to 50 you have to select two best possible answers. So this is very important. So from question 1 to question 45 you have to choose only one best possible answer, and from question 46, mean for last 5 questions you have to choose two best possible answers. On second page of exam paper you can also find some important data, mean values of some important constants are given to you, and also some prefixes are given, and also values of some trig functions are also given. So if you need value of any constant, any trig function, or if you need value of any prefix, you can come to this page and you can find values. If you go to the next page, on next page you can see some important formulae are given to you. First of all, try to remember these formulae so in the exam you can answer questions quickly. But if you have forgotten any formula and you need in your exam, you can come to this page and you can double check the formulae. So it's important to understand that these things are given to you in your exam. So if you need them, you can come and you can check. For this exam, we can use value of g equal to 10 meters per second per second. Now, if we go to question 1, for question 1, it is given to us an object is moving to the right with speed vi. When a force of magnitude F is exerted on it, in which of the following situations is the object's direction of motion changing, and kinetic energy decreasing at the instant shown? So in this case, as you can see, object is moving to the right and the initial speed of the object is vi. We need to find out direction is changing. So these two things we have to consider. Direction should be changing, direction changes, and ke decreases. Ke decreases. So these ke decreases. Direction of the object has to change when the force is exerted on the object, and kinetic energy of the object has to decrease. If kinetic energy decrease, it also means that speed has to decrease. So it means object has to slow down. Object has to slow down. Now we need to understand when object will slow down. For example, this is object. If this object is moving to the right, let's say its initial speed is to the right. If we apply force on this object in opposite direction, in this case object will slow down. So these concepts you need to understand. Object will slow down. Now you can also imagine that if object is moving to the right, let's say this is the initial speed of the object, and we apply force in the same direction as direction of motion, in this case object will speed up. Object will speed up, mean its kinetic energy will increase. We can also take another special case. Let's say object is moving to the right and we apply force on this object at an angle of 90 degrees. Let's say we apply force in this case upwards, or we apply force downwards. Only direction of motion will change. If this angle is 90 degree, in this case only direction changes. only direction changes. So the speed of the object will not change, but only its velocity will change. So direction of motion will change, because in this case work done is equal to 0. And so work done by this force is equal to 0. So the speed will remain constant. So we will say in this case speed does not change, or we can say speed remains constant. So these points you need to understand to answer this problem. Now we will go to the question and we will try to find the best possible answer. Now if you look at option A, in this case this force is at an angle of 90 degree to direction of motion of the object. So in this case only direction changes. So we will simply say direction changes only, speed will not change. So it means this is not possible answer. Direction has to change and speed has to decrease. But if you look at option B, in this case object will only slow down. I mean in this case speed will change, it will slow down. So this is also not best possible answer. If you look at option C, in this case we can resolve this force into two components. So one component is in direction of force, mean it will speed up. So we can say it will speed up, and one component means we can draw another component here. So due to this component of force is direction changes, direction changes. So two components. So let me redraw here. So we can draw, this is our object, this is direction of VI, so the force is here. So due to this force has two components. So let me use different color so you can have better idea. So if I resolve this force into two components, one component of this force is this way along direction of motion, so it will speed up due to this component, due to horizontal component, and due to vertical component of the force we can say FV, its direction will change. So it will speed up and direction changes, but we need to find out when it will slow down. So C is also not best possible answer. Means C is also incorrect. Now if we go to option D, in this case force is acting this way. So the best way to answer this question is first of all resolve this force into components. So this is one component and this is another component of force. So due to this component this object will slow down because this is in opposite direction of motion. So due to this component of force object will slow down. So we can say it will slow down, and due to this component direction will change, direction changes. So direction changes. So the answer for this question is D, direction changes and slow down. So the answer for this one is D. I hope you have some better understanding of this question, and also you have improved your conceptual understanding of forces and motion, mean how forces and motion they are linked together. Question 2 says a ball is suspended by a lightweight string. As shown in the figure above, the ball is displaced to position 1 and released. The 4 labeled positions are evenly spaced along the arc of the ball's motion, between which adjacent pairs of positions is the change in kinetic energy of the ball greatest. So we need to find out the positions where delta K is the greatest. Delta K is greatest, change in kinetic energy is greatest, not the kinetic energy is greatest. So in this case we need to understand, as the ball is falling down, ball is losing GPE. So we can simply write down GPE is lost, and loss in GPE has to be equal to gain in KE, kinetic energy gain, simply we can write down. So this has to be equal. And so if the loss in GPE is the greatest, it means gain in KE will be the greatest. So we can write on here loss in GPE. We can say that one simply will be equal to delta H mg delta H, and this one will be equal to change in kinetic energy delta K. So where delta H is greatest. So for that purpose, simply we can draw the lines here. We can draw these horizontal lines. So we can place this one here. So we have this horizontal line, and we can draw an other horizontal line here, and we can draw the last one, this horizontal line here. Now simply we need to understand delta H, where delta H is the greatest. So in this case, it is very obvious that delta K is greatest in first interval, mean between 1 and 2. So this is over delta H. So here you can see this is over delta H, and here we have this delta H. So delta H is greatest between 1 and 2. It means change in GPE is the greatest, so the change in KE is also the greatest. So the answer for this question has to be A, between 1 and 2. So this is a beautiful way to answer this question. I hope this question is clear to you. Question 3 says a newly discovered planet is found to have density 2 by 3 rho e and radius 2 re, where rho e and re are the density and radius of Earth respectively. The surface gravitational field of the planet is most nearly, means we need to find out value of g. So in this case we have two planets, so simply you can imagine that we have one planet. This is our beautiful planet. This is Earth, and we have another planet. So this is another planet, so we can say this planet is new planet. Simply we can say this is new. We need to find out value of g. So first of all, we can write down g. This is equal to g capital M over r square, mean the distance from the center of the planet to a point. So in this case we are only talking about surface, so it means r is the radius. It is given to us that radius of our planet, the density of our planet is given to us, that is rho sub e. So we can write down first of all this in terms of density. So we can say g, this is equal to capital G, M we can write down, volume 4 by 3 pi r cube times the density, and this is divided by r. So if we simplify this one, we can cancel. In this case we have r squared, so this is r squared, this is also r squared, so r squared we can cancel with this. Now if we simplify, we will get 4 by 3 capital G, and here we have pi, and we have r times density. In this case, this is constant. This is constant for these two planets. So this one is constant. So we can rewrite this. We will be writing here. So we can say in this case g over r times e. This is equal to some constant because this is constant. So this is constant for these two planets. So we can say this is equal to constant. So now we can write on here. So this is g for our planet over radius of our planet times the density of our planet. This one has to be equal to value of g on new planet, means value of g at the surface of new planet. We can say this is gn divided by radius of this planet we have, that is 2 times re, and the density of this planet is given to us, that is equal to 2 by 3 rho sub e. So we can plug in here, this is 2 times r, and here we have this is 2 by 3 rho sub e. So in this case, now simply we can cancel this re with this rho e, we can cancel with this rho e. So we have to find out in this case value of gn. So this is g sub n. So here we have this is 4 by 3. So if we rearrange this one, so in this case we can say gn, this is equal to 4 by 3 g sub e, and value of g on the surface of our planet we have, that is equal to 10. So here we have this is 40 divided by 3, so we will get around 13. So we will get 13. So 13 newtons per kg. So the answer for this question is D. So this is a way how you can approach this type of problems where ratio is involved. So we use ratio method, a best tool to answer when you have to compare two things, when you have to compare two different quantities. So this is the best way to answer this type of problem. So try to use this method more frequently so you can master this tool. And today's class we will just stop here, and in next video we will discuss the remaining questions. I hope this video was helpful. If this video has helped you to improve your conceptual understanding of these questions, please like and subscribe, and a lot of videos are coming about AP Physics 1 in near future. I'll see you in next video. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions for AP Physics 1. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics, and also you can have better understanding of these questions. Let's study together, let's improve together. Question 4 says, a bus is initially traveling north at a constant speed as shown in the figure above. As the bus starts to make a left turn without changing speed, a passenger notices that a box on the floor starts sliding toward right side of the bus. Which of the following top views of the box, when correctly labeled, would best represent all of the horizontal forces exerted on the box as it starts sliding? So in this case it is given to us the box starts sliding to the right, so it is sliding to the right. As the box is sliding to the right, there will be a horizontal force on the box, and horizontal force is only force of friction, and that horizontal force means the force of friction, it has to act to the left, mean opposite to direction of motion, because friction is opposing force. So this is direction of friction, and friction is opposing force, it opposes the motion. So simply we can write down friction opposes motion. Opposes motion in a very simple language you can understand. So if you understand this question, it is quite straightforward to answer this one. Box is sliding to the right, so the friction has to be to the left. So the answer for this question has to be B. For question number 5, we need to find out which block takes the longest time to reach the ground. If you look at given information for this question, it is given to us we have 3 identical blocks, each take a different path from a height h to reach the ground. Block A is released from rest and falls vertically, mean it just falls vertically. Block B is released also from rest and slides down a frictionless inclined plane. Block C is projected horizontally with an initial speed v. So we need to find out which block will take the longest time. So if you look at block A, so this will cover this vertical displacement. So this will cover this vertical displacement, and this vertical displacement is equal to small h. Vertical displacement, so this is equal to h, and vertical displacement of block C, this is also equal to h. And so we can also write down small letter h here. Now we need to look at the vertical motion of A and C. So simply we can say vertical motion of A and C, vertical motion. So we are talking about A and C only. So we will compare these two blocks first of all. So if you look at initial vertical velocity of block C, vertical velocity of block C is 0 because this is projected horizontally. Initially it has no speed along vertical direction. So we can say initial vertical velocity for these two blocks is equal to 0, and vertical acceleration is equal to g in this case, because only force acting along vertical, that force is force of gravity. So in this case height means the vertical displacement we have h. So this is the vertical displacement. So we can find out time taken from this point to the ground. So this time we need to calculate. As in this case, acceleration is constant, so simply we can use kinematic equations. S is equal to ut plus 1/2 at square. Initial vertical velocity is 0, so we can simply say h in this case will be equal to 0 plus 1/2 gt square. But one thing you need to understand is that in this case we are taking down is positive, so down is positive, so vertical displacement is positive and g is also positive. From here we can say that t is equal to 2h over g root of this. So as in this case, height of c and height of a is the same and value of g acceleration is also the same, so they will take the same time. So we can say a and c, they will take same time. A and c, they will take same time to reach the ground. Means they will hit the ground at the same time because the vertical motion is the same. Now if you look at block B, for block B we need to understand acceleration along this plane, and also you need to understand vertical displacement of A and C is shorter than the distance traveled by B. So we can say in this case h is shorter than this distance, is shorter than distance traveled by B. So means B will travel longer distance. And now if you look at acceleration of B, we can figure out, imagine that this angle is theta. This angle is theta, so we can draw forces acting on this block. So we have one force, that is mg, and other force is the normal reaction force. We can say this is n. We can resolve this weight into components, so we can resolve this one into two components. So we have this component, this is mg sine of theta, and this component is acting along the plane because this angle is theta, this angle is also theta. So mg sine theta is acting down the plane, so we can say f net is equal to ma. This is the resultant force acting on the block along the plane because there is no friction. F net is equal to ma. In this case, F net is equal to mg sine of theta, and this is equal to ma. So from here we can cancel this m with this m. So value of a, this is equal to g sine of theta. G sine of theta. A is equal to G if angle is 90 degrees. But as angle is lower than 90 degrees, it means that A is lower than G. So in this case, you can see one thing, A is lower than G, means acceleration of block B, we can also write on sub B. And the second thing is that distance traveled by B is longer than height, means the vertical displacement of A and C. So it means B will take longer time. So time taken by B, it will be longer than time taken by A or time taken by C. So the answer for this question has to be B because question is asking you the longest time. So the longest time is taken by B. So the answer for this question is B. So this is how you need to answer. One thing you need to understand is that if you throw any object horizontally with any velocity, or if you just drop the object, if vertical displacement is the same, time taken will be the same if we ignore air resistance. Very important concept. So if this point is clear to you, it means your concept about projectile motion, means the basic understanding of projectile motion is clear. For question number 6, we need to find out which block has the greatest speed just before hitting the ground. This question is simply based on law of conservation of energy, or simply we can say in this case simply based on law of conservation of mechanical energy, because in this case there is no any other resistive force, means we are ignoring friction, we are also ignoring air resistance. So we can apply law of conservation of mechanical energy. For block A, if we apply for block A, simply we can write down for A. For A, initial energy is only potential energy, so this is mgh, and this one has to be equal to the final kinetic energy, 1/2 mv square. So this is for block A. In this case, our reference line, very important. So our reference line, or we can say reference level, is ground. At this point we are taking H is equal to 0, height is equal to 0. So all the potential energy will be converted into kinetic energy when the block just before hitting the ground. So this is for block A. For block B, we can also write down the loss in GPE of block B. This is equal to mgh, because vertical height is the same, and gain in kinetic energy also will be equal to 1/2 mv square. So block A and block B, they will have the same speed. We can also write down speed from here, v, so mass will be cancelled. This will be equal to 2gh, root of 2gh. And for block B, we can also write down v. This is equal to 2gh, root of this one. So block A and block B, they will have the same speed when they hit the ground. Now if you look at block C, for block C, initial energy, initial mechanical energy, this one has to be equal to final mechanical energy. Initial mechanical energy, it has initial speed, that is 1/2 m v naught square, plus loss in GP, means it has initial GPE. This one has to be equal to final kinetic energy, because final GPE is equal to 0. So I'm not writing 0 here. So in this case, again we can cancel m with m, so this m will be cancelled. So in this case, v square, this will be equal to v naught square divided by 2 plus gh, so this is v square divided by 2. Now we can write down in this case v square, this will be equal to v naught square plus 2gh. So we need to calculate v in this case. So v simply will be equal to v naught square plus 2gh, root of this one. So you can see in this case the speed of C. So this is speed of C, this is speed of A, and this is speed of B. So in this case, it is very clear that VC is greater than VA and is also greater than VB, because this has this extra amount of speed. So C has the greatest speed. So the answer for this question is C. A beautiful question based on conservation of energy, and most of the time many students, they just ignore this initial speed, they just ignore this initial kinetic energy. Question number 7 says a ball is dropped from rest and falls to the floor. The initial gravitational potential energy of the ball earth floor system is 10 joules. The ball then bounces back to a height where the GPE is equal to 7 joules. What was the mechanical energy of the ball earth floor system the instant ball left the floor? So very simple question, just little bit tricky one. So the best way to answer this question is, we can first of all imagine this one is the ground. So this one is the floor, and the ball is dropped from certain height, and GPE of the ball at this point, this is equal to 10 joules. So this is the initial. Then it is given to us the ball hit the floor, and when just the instant ball left the floor, so we can imagine when the ball is here, the ball is here at this point, we need to find out what is the mechanical energy of the ball. And also it is given to us this ball bounces back to certain height, it bounces back to this height, and GPE of the ball at this point, means the GPE of the system, this is equal to 7 joule. So it bounces back to this height, and GPE at this height is equal to 7 joules. We need to find out what is mechanical energy at this point. So in this case, we are taking ground as our reference level. So ground is reference level, means GPE here is equal to 0. So if Gp is equal to 0, so at this point the mechanical energy of the ball, we can say Me, the mechanical energy of the ball, this is only equal to kinetic energy of the ball, because Gpe of the ball is equal to 0. So let me write on here plus Gpe at this point. So in this case Gpe is equal to 0. So we can say the mechanical energy of the ball, this is only equal to kinetic energy of the ball. As in this case there is no air resistance, so when the ball will rise, its kinetic energy will be converted into Gpe. So at this point we can say kinetic energy has to be equal to 7 joules. So the mechanical energy of the ball when it just leave the ground, mechanical energy has to be equal to 7 joules by conservation of mechanical energy. So here ball has kinetic energy. At this point kinetic energy will be converted into Gpe. So the answer for this question has to be C. Question 8 says a disk is initially rotating counterclockwise around a fixed axis with angular speed omega naught. At time t is equal to 0, two forces shown in the figure are exerted on the disk. If counterclockwise is taken as positive, which of the following could show the angular velocity of the disk as a function of time? Mean how angular velocity is changing with time. So the first thing, simply we can say in this case counterclockwise we have to take positive. So initial angular velocity also has to be positive. So now if you look at given options, option A is incorrect because this is showing initial angular velocity is negative, and option B is also incorrect because this is also showing initial angular velocity is negative. So the answer is C, our answer is D. Now if you look at this given system, in this case the net torque is counterclockwise, so net torque is clockwise, so the net torque tau net, this one is clockwise because this force is bigger, so the net torque on this disk is clockwise. As net torque is clockwise, and we understand torque is equal to I times alpha, so tau net and alpha, they must have the same direction. So it means that in this case alpha, this is clockwise and clockwise is negative, and clockwise is negative. So alpha, this is equal to delta omega over delta t, delta omega over t. It simply means that the gradient of omega against time graph, so if we take omega on y-axis, t on x-axis, the gradient of this one, gradient will be equal to alpha. So gradient of omega against time graph, this is equal to alpha, and alpha is negative, so the gradient has to be negative. As alpha is constant, so gradient also has to be constant. So we can say alpha is negative and alpha is constant because net torque is constant, so simply we can write down constant here. So the gradient of omega against time graph has to be, means the gradient has to be constant, gradient has to be constant, and gradient has to be negative, constant and negative. So option C is the best answer because this gradient is constant and this gradient is negative. So the answer for this question is C. So in this case, first of all, disk is rotating counterclockwise, but net torque is clockwise, so this disk will start slowing down, and finally omega will be 0, and then omega will be negative, means omega will be clockwise. So this feeling is also important. You need to understand what is happening. So at this point, after this period of time, omega will be 0. Before this one, omega is positive. After this, omega will be negative. But acceleration means the rate of change of angular velocity is constant. Question 9 says a 50 Newton box is at rest on a horizontal surface. The coefficient of static friction between the box and the surface is 0.50 and the coefficient of kinetic friction is 0.30. A horizontal force of 20 newtons is exerted on the box. the magnitude of acceleration of the box is most nearly. So we have to calculate magnitude of acceleration of the box. Means block has to move. So first of all, we can sketch. So simply we can sketch our block, and this block is placed on a horizontal surface. The weight of the block is 50 newtons, so we can draw the weight of the block. This is 50 newtons. So this is weight of the block, that is equal to 50 newtons. And normal reaction force on this block also has to be equal to 50 newtons. So this is normal reaction force, because block is not accelerating vertically up and down. So normal reaction force is equal to 50 newtons. So first of all, we can find out in this case is the block is moving or not. In this case, it is given to us the force acting on this box to the right is 20 newtons. So this is the force acting on this. Now we can find out maximum force, means the limiting value of static friction. Maximum value of static friction, we can say this is Fs. So Fs in this case will be equal to mu times n. So this is the maximum value of friction, limiting friction, maximum. So mu in this case we have that is equal to 0.5, and we have normal reaction force that is equal to 50. So if we solve this one, we will get 25 newtons. So the maximum value of static friction in this case is equal to 25 newtons, and 25 newtons is greater than 20. So it simply means that as Fs maximum, this is greater than 20 newtons, it means block will not move. Block will stay at rest, not move. As block will not move in this case, so it means acceleration of the block simply will be equal to 0 meter per second per second. So the answer for this question has to be A. So always check is the block is moving or not. So this is just a tricky question, so you have to solve this one. You have to check is the applied force greater than maximum value of friction or not, means the maximum value of static friction. If applied force is greater, block will move, block will accelerate, it means there will be resultant force, and then you can calculate acceleration using coefficient of kinetic friction. But in this case, block is not moving, so acceleration is equal to 0 meters per second per second. Question 10 says a thin rod of length d on a frictionless surface is pivoted about one end as shown above and can rotate freely. The rod is at rest when it is struck by a sphere with linear momentum of magnitude pi perpendicular to the rod. The sphere rebounds along its original line of motion with momentum of magnitude pf. What is the magnitude of the angular momentum of the rod immediately after the collision? So in this case, first of all, we can write down angular momentum. Angular momentum is equal to r cross p. R, we can say this is equal to rp sine of theta, and theta is the angle between linear momentum and r. In this case, theta is equal to 90 degree because it is given to us perpendicular to the rod, so theta is equal to 90 degrees. So simply we can say in this case angular momentum is equal to rp. R, we can say this is equal to mv times r. In this case, r is equal to d, so we can say this is equal to mv times d. So we can also calculate change in angular momentum by simply writing that final linear momentum minus initial linear momentum times d for sphere. So we are talking about sphere here. So in this case, the initial linear momentum, we can also look at angular momentum, but simply you can take the linear momentum. In this case, angular momentum is counterclockwise. In this case, angular momentum will be counterclockwise, and in this case, angular momentum will be clockwise. So here we have angular momentum that is counterclockwise, here it is clockwise. So in this case, we will take clockwise positive, or we will take linear momentum downward as positive, and this one we will take negative. So this one will be negative and this one will be positive. So now we can write down here. So this is pf minus into minus pi. So minus pi, and this is multiplied by d. So simply the change in magnitude of angular momentum, this is equal to pf plus pi times d. So this is the change in angular momentum of sphere. As in this collision, for this system, total change in angular momentum has to be 0. So the change in angular momentum of this rod also has to be equal to pf plus pi times d. So this is for the rod. So change in magnitude of sphere, change in magnitude of angular momentum of sphere, this one has to be equal to change in magnitude of angular momentum of the rod, because in any collision angular momentum is conserved. So the answer for this question has to be D. Question 11 says a spacecraft is placed in a circular orbit around a planet with mass equal to 6.4 times 10 to 23 kgs. The spacecraft orbits at a height of 4.5 times 10 to 7 meters above the planet's surface. What additional information is needed to calculate the speed of the spacecraft in the orbit? So for this question, simply we need to calculate orbital speed. So v orbital, so we can say v orbitals, orbital speed. Then orbital speed simply is equal to gm over r, or we can say gm over r, but this r is representing distance from the center of the planet to that point. So we can simply, this is root of gm over r. We can also derive this formula. You can simply use Newton's law of gravitation, g capital M small m over r square. This is equal to m v square divided by r. So this is small m. So we can cancel with this one. In this case 1r we can cancel with this. So v simply is equal to g capital M divided by r. So this is how you can calculate orbital speed. But you need to understand the meaning of this symbol. G is a universal gravitational constant, and this m is the mass of planet. So capital M is mass of planet. Mass of planet, and r is the distance from center of planet. So r is distance from center of planet. Center of planet is not the radius from center of planet. So in this case simply we can sketch. We have this beautiful planet. So let's say the radius of this planet, this is equal to small r, and the satellite is orbiting, spacecraft is orbiting at this point. In the question we have this height. This height is given to us. So we can say this height is h, and this is given to us in the question. This height is given. Now we need to calculate the orbital speed of this spacecraft. So what do we need? So if we rewrite the formula, we will write on this is g times capital M divided by r plus h. So this is orbital speed, and in this case we have value of this. G is a constant. We have value of this as well. I mean, this height is given to us, that is equal to 4.5 times 10 to 7 meters, means height from the surface of the planet. So if we have value of r, we can calculate orbital speed. So simply we need planet radius. So we can say planet's radius we need if we need to calculate orbital speed. So the answer for this question has to be B. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions for AP Physics 1. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics, and also you can have better understanding of these questions. In the last two videos we have discussed from question 1 to question 11, and for those solutions you can go to the channel and you can search for AP Physics 1 Practice Exam 2 Part 01 and Part 02. And also if you have any questions from any paper, you can leave your questions in comments and I will try to answer as soon as possible. Let's study together, let's improve together. Question 12 says two cars of mass 2m and m approach each other head-on with the same speed v as shown in the figure above. When the cars collide, they hook together. Assuming positive momentum is to the right, which of the following best represents the momentum of the car of mass m as a function of time before and after the collision? So we have to focus on momentum of car with mass m. So in this case you can see the momentum of mass 2m, this one is to the right, so this momentum we have to take positive, then this one has to be negative. So simply we can use conservation of momentum. In this case we can say momentum before, this one has to be equal to momentum after collision. Momentum after collision, so momentum is always conserved before collision and after collision if there is no net external force acting on the system. So in this case this is our system and we are assuming that there is no net force acting on the system, means no net force is acting on these two cars. So the momentum before and momentum after has to be equal. So if you look at momentum before, in this case momentum of this car we are taking to the right positive because this is given in the question. You have to take to the right as positive. Even if it is not given in the question, by convention we take to the right positive and we take upwards also positive if it is not specified in the question. So in this case it is specified in the question that momentum to the right is positive, so we are taking to the right is positive. So momentum of this car, this is equal to 2mv plus momentum of this car, and this is m times minus v, this momentum is negative. And after collision these two cars they stick together, so we can also draw here they stick together. So we have car 1, the mass of this one is 2m and the mass of the second car is m. They stick together and they have to move actually to the right to conserve momentum, because net momentum before collision we have to the right. So these two cars when they stick together, net momentum has to be to the right after collision as well, because momentum has to be conserved for this system because there is no net external force acting on this system. So if we have this understanding, so simply we can write down in this case m plus 2m times v. So this is v, so we can find out value of v from here. We can say this is v final, so we can avoid confusion. V final, we can say vf. So vf in this case will be equal to mv, so 2mv minus mv, we will get mv, divided by we have 3m. So from here we can cancel m with m, so simply we left with v by 3. So this is the final velocity, and this is the velocity of cart of mass 2m and also velocity of cart of mass m, and this is equal to v by 3. So we can write down the momentum after collision of mass m. So we can write down after collision momentum of m, p of m, this is equal to m times v by 3, and this momentum is positive. And before collision momentum of m, so we can also write down before collision. Before collision momentum of m is p, we can say before, so we can write down here pf, here we can say p initial. P initial is equal to minus mv. So if you look at given options, this is telling us that there is no change in momentum of mass m, so this is incorrect. This is telling us initially it is negative and after collision is still negative, after collision it is positive, so this is also incorrect. Magnitude is the same, so this is also incorrect because magnitude after collision is lower, so this is also incorrect. So the answer for this question is C. C is correct option because this momentum is minus mv and this momentum is mv by 3. So the answer for this one is C. Question 13 says a student stands at one end of a raft floating in a pool with equally spaced marks along the bottom as shown above. The student and raft, they have the same mass. The student walks to the opposite end of the raft. Which of the following best shows the final locations of the raft and student relative to the marks at the bottom of the pool? Assume that no drag force between the raft and the water. Means between water and raft there is no friction, there is no drag force. So the best way to answer this question is, in this case it is given to us boy and the raft, they have the same mass. So we can mark the center of mass of the system first of all. So in this case the center of mass of the raft we can mark first of all. So this one will be along this line, means at the center of the raft. We are assuming it is a uniform, so its center of mass is at its midpoint. So center of mass of the raft is here. Now boy and the raft, they have the same mass, so it means the center of mass of this whole system, it will be between these two objects, mean between boy and the raft. So center of mass of this system we can mark somewhere here between them. Now we can also do the marking. So this is 0 1 2, so this is center of mass is at 2.5. so this is location of center of mass of this system. As in this case there is no net external force acting on the system, so we can say no net external force acting on the system, no net external force on the system. So it means that the center of mass will stay at rest. If center of mass is at rest, if no external force is acting on the system, center of mass stay at rest. If the center of mass is moving with constant velocity, if no external force acting on the system, center of mass will keep on moving with the same constant velocity. So this point is very important. No net external force on the system. As in this case they are at rest, it means center of mass will stay at rest. We can say center of mass stays at rest in this case. So this is the main concept, stays at rest, because initially center of mass is at rest and it will stay at rest if there is no net external force acting on the system. If initially center of mass, let's say it was moving with constant velocity, then it will continue with the same constant velocity if no net external force acting on the system. Constant velocity. So this concept is important. So now we need to find center of mass has to be at 2.5. So this is the main concept. Center of mass has to be at 2.5. So we can mark here. So in this case the boy is here, so the center of mass will be along this line. So it will be here. So this center of mass is not at 2.5. So it means this option is not possible. So this one is incorrect. And if we mark center of mass here, so center of mass will be along this line. Center of mass will be between the center of boy and the center of mass of this raft. So it will be here at this point. So and this point is also not at 2.5. It is not at 2.5. So it means this option is also incorrect. So B is also incorrect. If we look at C, for C we can see center of mass of the raft is here. So this is center of mass of the raft, and center of mass of the boy is here. So it is 3. So the center of mass of the system, it will be halfway. It will be between these two centers. So it will be here. So this answer seems correct because this is also 2.5. So the answer for this question is C. This is also incorrect because center of mass in this case is here, and this is 1.5. So this is also incorrect. So this is how you can approach this problem. I hope this question is clear to you. Question 14 says a circuit is designed with two resistors. R1 is equal to 200 ohms and R2 is equal to 400 ohms, and a battery with internal resistance R is equal to 10 ohms as shown above. What is the relationship between three labeled currents, means I1 and I2. So first thing we need to understand, as all these components, they are connected in series, it means charge has only one way to flow. So current passing through each resistor has to be the same. As these components, they are connected in series, so same current passing through each resistor, each component, same current. So it simply means that I has to be equal to I1 and I1 has to be equal to I2. So the answer for this question is D. Question 15 says, when two charged massive objects are placed a distance r apart, the gravitational force between them has magnitude F. When the distance between the objects is increased to 2r, the magnitude of gravitational force between them becomes F by 4. Did electrostatic force between the objects also decrease to 1/4 of its initial magnitude as a result of the change in position, and why? So for this question, we need to understand first of all how gravitational force change with distance. Gravitational force is equal to G capital M small m over r square. R is the distance between centers of these two masses. From here we can simply say gravitational force is inversely proportional to r square. And if you look at electrostatic force also obey inverse square law. So this is divided by r square. From here we can see electrostatic force means Fe, electrostatic force. This is also inversely proportional to r square. So it simply means that these two forces, they obey inverse square law. Inverse square law, very important concept, inverse square law. So the magnitude will decrease by the same amount, but the magnitude will not be same. Decrease by same amount because they follow inverse square law, but these two forces, the magnitude will be different. Now if you look at option A, it is given to us no. So this is incorrect. B is also incorrect, no. If you look at option C, this is given to us yes, it obey inverse square law. So yes, this is right. Because both forces have the same 1 over r square dependence, means both forces, they obey inverse square law. So it means option C is correct. D, yes, this part is right, because the gravitational force always equals, no, not equal. So not equal, so this is wrong. Not equals electrostatic force at any given distance, means they have different magnitude. This is telling us they have the same magnitude, so this option is also incorrect. Question 16 says a clay ball and a rubber ball of the same mass are moving toward a glider that is at rest on a frictionless air track. The balls have the same speed, with the rubber ball moving to the right and clay ball moving to the left, as shown above. The balls strike the glider at the same time. The clay ball sticks to the glider and the rubber ball bounces off glider. Which of the following indicates the direction of motion of the glider after the collision, and explain why it moves in that direction? So for this question, we simply need to understand the forces exerted by these two balls on the glider. If one ball exerts more force, it means that this glider will move in direction of that force. So let's try to calculate first of all change in momentum of these two balls. If you look at rubber ball first of all, so simply we can say rubber ball. This ball is moving to the right, so we can write down mass of this one is m and the speed of this one is v. And we can also imagine glider at this point. So this one is the glider. So this one is glider. When this rubber ball collides with this glider, this bounces back. We can just imagine speed after collision is also v, and the mass of this one is m. So the change in momentum of this ball, if we take in this case to the left positive, we will take this velocity positive. So we have mv minus we have m, so this velocity has to be negative, so we have minus v. Now if we solve this one, we will get mv plus mv. So the change in momentum of the rubber ball, this one is 2 mv, and this change in momentum is to the left. because this is positive. So change in momentum of the glider, it has to be to the right. So change in momentum of the glider, this one has to be to the right. We can also calculate force on glider by the ball. Force on glider, this one will be equal to the change in momentum of glider divided by time. So change in momentum of the glider, because change in momentum of rubber ball is to the left, so change in momentum of the glider, this one has to be to the right. So it means force on glider is to the right, and this force will be equal to 2mv divided by delta t, the time the rubber ball is in contact with the glider. We can do the same for clay ball. We can write on here, we have clay ball. For the clay ball, we have glider here, and the ball is moving to the left. So ball has mass m and it has velocity v. So in this case, this ball is moving to the left. So after clearing this, stick with this one. As this ball is moving to the left, we can take, in this case, we can take the same direction as positive. So we can take to the left also positive for this one. So we can write down change in momentum. So we have, this is, as this speed is 0, so we can say final momentum is equal to 0, and we have minus, and we have, this is m, and we have, this is v. So in this case, we will get change in momentum is minus mv. Change in momentum, so this is minus mv is simply telling us that change in momentum of the ball is to the right. Delta p is equal to mv, and this is to the right. Change in momentum is to the right. This one is for the ball, for the clay ball. Now if we write down the force on glider due to clay ball, force on glider, this one has to be equal to mv divided by delta t. As change in momentum of the ball is to the right, so change in momentum of the glider, this one has to be to the left. Change in momentum of the glider, this one has to be to the left. So in this case, we can see the change in momentum of glider due to the clay ball, it is smaller, mean this quantity is smaller and this quantity is greater. So it means glider, in this case, this will move to the right. So glider will move to the right. So we can write on here, glider moves to the right. So glider moves to the right. So this is the point we need to understand, moves to the right. Why it moves to the right? The reason is that 2mv over delta t, this is due to the rubber ball. The change in momentum means the force on the glider due to the rubber ball, this is greater than force on glider due to clay ball. So we can also write on delta t. We are just talking about same amount of time. So this is due to clay ball. So it means rubber ball in this case will exert more force, and direction of force on glider is to the right. So this glider will move to the right. So if you look at given options, it is given to us for option A, glider moves to the right. Yes, this part is right, because the magnitude of change in momentum of the rubber ball is greater than the magnitude of the change in momentum of the clay ball. That's right, because this change in momentum, this one is greater than this change in momentum. So it means option A is correct. Rest of the option, they are incorrect. So the answer for this question is A. Question 17 says a lion is running at constant speed toward a gazelle that is standing still, as shown in the top figure above. After several seconds, the gazelle notices the lion and accelerates directly toward him, hoping to pass the lion and force him to reverse direction. As the gazelle accelerates toward and past the lion changes direction and accelerates in pursuit of the gazelle. The lion and gazelle eventually each reach constant but different speeds. Which of the following sets of graphs shows a reasonable representation of the velocities of the lion and the gazelle as function of time? So the best way to answer this question is we can divide this one into three different parts. We can say this is one, and this is second, and this one is third. In first part, lion is moving to the left. and the speed of the lion is constant. So we can write down speed of lion is constant speed, and it is moving to the left. As in this question, it is not given to us which direction we have to take positive. So by convention, in this case, we will be taking to the right as positive. So we have to take in this case to the right as positive. So initially, as lion is moving to the left, so its initial velocity has to be negative. So it means C is not possible and D is also not possible. So answer can be A or answer can be B because this is negative. And also we need to understand gazelle initial velocity is 0. Initially it was at rest. But in this case, if we look at this one, initially at rest for several seconds, after several seconds, means it's still at rest. Now this is telling us that this one has certain velocity. At time t0, its velocity is 0. After its speed is increasing, accelerating, this is incorrect. So the answer has to be A for this one. So this is how we can figure out, but further we can discuss more about A. At this point, after few seconds, gazelle accelerates to the right. So accelerates to the right. So its velocity has to be positive. Accelerate, velocity has to increase. Then gazelle at this point reaches constant velocity. So it reaches constant speed and also constant velocity because it is moving in the same direction. It is moving to the right. So it has to be positive, constant and positive. And velocity of gazelle here also has to be positive. And this is increasing velocity. It is accelerating. So this graph is correct. Now if you look at motion of the lion, first of all, lion has constant speed, so it has constant speed. Then lion changes direction, so its speed will decrease to 0, and then it accelerates. So it changes the direction. So first of all, its velocity is constant, it is moving to the left, then it changes direction. So its velocity become 0 here, and then it start increasing, accelerate, finally continue moving to the right with constant velocity. V is positive. So the answer for this question is A. So this is how we can understand. So how we can eliminate? So in this case, you have seen we have eliminated C and D first of all, then we have eliminated B as well. So this one is the answer. So this technique you can use in your exam to answer these questions quickly. Question 18 says a spacecraft of mass 4000 kgs is traveling in a straight line in the positive direction. Engines can be fired so that the force exerted on the spacecraft is in the positive or negative direction. The graph above shows data for the force during one interval. Which of the following is the best estimate of the net change in the speed of the spacecraft from time t is equal to 0 to time t is equal to 4 seconds? If you look at the graph, in this case we can see the force is positive until 2 seconds, then there is no force, and then force is negative. So here in this interval we have force positive. From 0 to 2 seconds we have force that is positive, so we can say this is in upward direction, and between 2 to 3 seconds F is equal to 0, there is no force, and between 3 to 4 seconds there is force on the spacecraft, but direction of this force is negative, meaning this force is downwards. We need to calculate the net change in the speed of the rocket. So in this case, rocket will speed up, so we can write down speed up, and due to this force rocket will slow down. So we have to find out net change in the speed in this interval. So first of all, in this case we can draw the best fit line. So from here we can draw the best fit line. So our best estimate can be triangle, and here we can also draw the line. So we can draw a horizontal line. So this can be the best estimate for this interval of time. So we can calculate area, because area here is equal to change in momentum. So this area is equal to change in momentum. Area under FT graph, this is equal to change in momentum. So we can calculate this area. This area is representing change in momentum. So this is delta P. And this delta P is positive. So this area is also change in momentum. And this change in momentum is negative. And this area we can simply calculate. This is area of triangle. So we have 1/2. We have time. This is 2, means x-axis, the base of this triangle. Time, we have the height of triangle, that is equal to 1000. So in this case simply we will get 1000. So this is change in momentum, means this is kg meter per second, or we can say this is Newton second. And this area we can also calculate. This change in momentum will be equal to area of rectangle. So we have time, that is equal to 1 seconds, and we have force, that is about 500. So this is negative. So in this case we will get negative 500 Newton second. So we need to calculate total change in momentum. So we can say delta P total. Delta P total in this case will be equal to 1000 plus this is minus, then this become minus, so we have minus 500. So we will get total change in momentum. This is equal to 500 newtons second. So this is total change. Change in momentum, we also need to understand change in momentum is equal to m times delta V. We need to calculate delta V. So delta V simply will be equal to 500 divided by 4000. So we have 4000. So these two zeros we can cancel with this one. And so simply we left with 5. So we can simply cancel here. We will get, in this case, this will be equal to about 0.125 meters per second. So this delta V is positive. So then so far this question has to be B, and this is how you can calculate. Question 19 says a rocket is continuously firing its engines as it accelerates away from Earth. For the first kilometer of its ascent, the mass of fuel ejected is small compared to the mass of the rocket. For this distance, which of the following indicates the changes, if any, in the kinetic energy of the rocket, the gravitational potential energy of the Earth rocket system, and the mechanical energy of the Earth rocket system? So in this case, first of all, we need to understand, as rocket in this case is accelerating upward, so the kinetic energy of the rocket is increasing. So this is simply, you can imagine this one is the rocket. As rocket is accelerating upwards, so it is given to us, it is accelerating upwards, so it simply means that its speed is increasing. As speed is increasing, it means that kinetic energy of the rocket is increasing. As rocket is also gaining height, it also means that GPE is also increasing. We can also say delta KE, this is positive, change in kinetic energy is positive, and change in GPE is also positive. And so kinetic energy is increasing of the rocket, and GPE of Earth rocket system is also increasing. Now we need to understand mechanical energy, ME, mechanical energy. Mechanical energy is the sum of kinetic energy and potential energy, gravitational potential energy, change in mechanical energy. As this sum is positive, means change in kinetic energy is positive, and change in GPE is also positive. It means that change in KE is also positive, means the change in ME is also positive. So ME is also increasing. So all these three types of energies, they are increasing. So answer has to be A, kinetic energy of the rocket is increasing, and potential energy of the system is increasing, and system mechanical energy is also increasing. So the answer for this question is A. Question 20 says block 1 is attached to a spring and oscillates on a horizontal frictionless surface. When block 1 is at a point of maximum displacement, block 2 is placed on top of it from directly above without interrupting the oscillation, and the two blocks stick together. How do the maximum kinetic energy and period of oscillation with both blocks compared to those of block 1 alone? So in this case, simply first of all we can sketch. So we have first of all one spring and one block is attached with this one. And when this block is at the maximum displacement, so simply we can imagine at this point maximum, so here we can say the minimum displacement, we place an other block on the top of first one. So we can redraw this. And so when the first block is at this point, we place another block on the top of this. Now we need to compare the time period of these two, and we need to compare the kinetic energy. Kinetic energy in these two cases. We can say this is case 1 and we can say this is case B. For time period, we need to understand for oscillating spring mass system, time period is equal to 2 pi m over k. So 2 pi m over k. And kinetic energy, we need to understand kinetic energy means the kinetic energy is the energy of the system, spring mass system, when the block is at this point, and at this point speed is maximum. So at equilibrium, kinetic energy is also maximum. And at this point kinetic energy is 0 at extreme point, but EPE is maximum. EPE is maximum because displacement is maximum. And so in this case, simply EPE will be converted into kinetic energy, and then kinetic energy will be converted into EPE, and this process will repeat again and again. So if you look at EPE, in this case EPE is equal to 1/2 kx square. In this case, k is not changing, x is not changing, it means EPE remains constant, and KE is equal to EPE. KE is equal to EP. They just change the positions, but total energy, we can also say total energy is equal to kinetic energy, total E. This is equal to kinetic energy at equilibrium, and total energy is equal to EPE at extreme position, mean at maximum displacement. So they just energy change. When the block is at this point, system has EPE, and when the block is here, system has kinetic energy, and so on. So this process keep on repeating. And so in this case, as this one is not changing, it means kinetic energy also will not change. We can also say kinetic energy is equal to 1/2 kx square. As this remains constant, Ke also remains constant if we place another block on the top of first one without disturbing the system. And also in this case, we are ignoring there is no friction. So kinetic energy will remain constant, but time period will get smaller. Time period will get longer because when m increase, it means time period will increase. So Ke has to be the same. So A is not possible, B is not possible, C same, yes it is possible, but this one is wrong. Time period has to get longer, greater. So the answer for this question is D. So the main concept is you need to understand this formula, and you need to understand total energy is equal to EPE when the block is at maximum displacement, and total energy is equal to Ke when the block is at equilibrium, and when the block is again at maximum displacement, total energy is equal to EPE again. And this process keep on repeating. As in this case, x is the same, k is the same, it means Ke also is same. So the answer for this question is D. So we have done 20 questions from this practice exam, and these 20 questions are very useful for your AP Physics 1. So go through these questions, try to understand. Where you have questions, you need more help, you can leave your questions in comments and I will try to answer as soon as possible. See you in next video. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions for AP Physics 1. In the last few videos, we have discussed from question 1 to question 20, and today's lesson, we will start from question 21. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics, and also you can have better understanding of these questions. Let's study together, let's improve together. Question 21 says a child slides from rest down slides A and B as shown above. The slides are the same height and the coefficient of friction between the slides and the child is the same. Which of the following compares the change delta K in the kinetic energy of the child and change delta U in the potential energy of the child earth system for the two slides? So this question is just simply based on conservation of energy. If your concept of conservation of energy is clear, simply we can answer this question. In this case, you can see first of all they have the same height. It means they have the same potential energy. So the change in potential energy is the same. So if work done by friction is greater, it means that change in kinetic energy will be lower. If the work done by friction is smaller, change in kinetic energy will be greater. So simply we can answer this question like this. Now let me explain you this question in detail. So if you want to understand this whole concept in detail, so you can see here these two slides, they have the same initial height. Now we will use conservation of energy. So first of all, simply we can say initial energy of the system means initial total energy. This one has to be equal to total final energy. Initial energy we have only, that is GPE initial. GPE initial. So if you wanna write down in detail, we can also write down this one in detail. So maybe it will help you to understand the concept better. So we have initial GPE, we can say GP initial, plus we can say we have initial kinetic energy. This one has to be equal to GPE final plus kinetic energy final plus work done against friction. Now we can rearrange this one. So we can write down GPE initial minus we have GPE final. This one has to be equal to kinetic energy final minus kinetic energy initial plus work done against friction. Now we can write down this one in terms of change in potential energy. We can say delta GPE. This one has to be equal to delta KE plus work done against friction. In this case, change in GPE is the same. So if the work done is greater, we can rewrite this one. We can say this is delta KE plus force of friction times the distance travel. If you look at A, in this case distance travel is only this much, and in this case the distance travel is much longer. So this distance travel is longer, but force of friction is the same. As friction in this case is the same, and if distance travel is longer, it means that work done against friction will be greater. If work done against friction is greater, it means the change in KE will be lower. So this change will be lower. So in this case, delta K will be lower because work done against friction is greater. And in this case, delta KE will be greater because work done against friction is lower. So the change in delta K for A is greater. So first one is not possible. Second one also incorrect. Third one can be possible. Change in delta K is greater than change in K for B. And so this one is correct because this is the same. This is correct, but this one is incorrect. So the answer for this question is C. Question 22 says a student is observing an object of unknown mass that is oscillating horizontally at the end of an ideal spring. The student measures the object's period of oscillations with a stopwatch. The student wishes to determine the spring constant of the spring using the measurements of the period of oscillations. Which of the following pieces of equipment would provide an other measured quantity that is sufficient information to complete the determination of the spring constant? So for this question, it is given to us. We have unknown mass that is oscillating at the end of an ideal spring. So this is our spring mass system. We can also imagine this one. If we pull this one to the right to the extreme position here and then we let it go, it will start oscillating like this. and then it will return to this extreme position. I mean, it will oscillate between these positions. So you can imagine spring mass system is oscillating horizontally. So we need to understand how we can determine the time period of spring mass system. Time period of spring mass system, simply T is equal to 2 pi m over k. M is the mass attached at the end of the spring. I mean, this mass, this is not mass of the spring. In this case we are talking about ideal spring, means spring is massless, spring has no mass. So only you need to take the mass at the end of the spring. So this is that mass, and k is spring constant. So if we need to determine spring constant and we have this quantity already, so simply we need m, and to measure m we need balance. So we can measure m with the help of balance. So the answer for this question has to be C. Question 23 says, using a number of measurements, the student determines the following: spring constant, mass of object, amplitude of oscillations, and maximum speed of object. And we need to determine total energy of spring mass system. So the total energy of spring mass system we can determine using different ways. One way to determine total energy of the spring mass system is we can simply calculate by EPE, means total energy of the system is equal to EPE. So we can use 1/2 kx square. So in this case we are talking about the maximum energy, means the total energy. So this is the amplitude. Now if we plug in values we can find the answer, because we have value of k is given to us, that is equal to 85 newtons per meter, and we have amplitude of oscillations, that is equal to 0.30 meters square. If we solve this one, our answer will be around 3.8 joules. So the answer for this question has to be B. But you can also calculate total energy of the system when it is at equilibrium. Then total energy will be equal to Ke max, and we can calculate simply by 1/2 mv max square. So in this case we have mass attached with the spring, and the value of mass is given, that is 0.50, and we have V max, that is 3.9. So we have 3.9 square. If we solve this one, we will also get about 3.8 joules. So this is the answer. Question 24 says, while the object is continuously oscillating, the student determines the maximum speed of the object during two oscillations. The first speed is 3.5 meters per second, and the second speed is 2.7 meters per second. Which of the following could account for the decrease in the object's maximum kinetic energy? So for this one, we need to understand first of all a little bit more about our horizontal spring mass system. In this question we are talking about horizontal spring mass system, mean when the mass is oscillating horizontally. So this is the equilibrium position, so we can write down this is equilibrium. So this is equilibrium. Then we pull this spring to the right, so you can imagine we pull this one to this position. So this is the extreme position, and in this case this is the maximum displacement. So this is the amplitude, or we can say this is x max. And at this point, total energy of the system, this will be equal to EPE, and EPE is maximum, and this is equal to total energy of the system. But if you look at equilibrium kinetic energy is maximum, and this is the total energy of ideal spring mass system. And also we can draw this mass here when the spring will be compressed. So at this point is also true, EPE will be maximum. So we can say EPE will be maximum, and this is equal to total energy. But at this point Ke will be equal to 0, and here Ke also will be equal to 0. Now we need to understand the relationship between them. So if you look at equilibrium, you can see kinetic energy is changing into EPE when this mass is moving to the right, and vice versa is true when the mass is moving to the left. So EPE will change back into kinetic energy. And when this mass is moving from equilibrium to the left, kinetic energy will change into EPE, and when it is moving to the right, EPE will change into KE. So these are the main concepts you need to understand. If this is clear to you, now we can go to given options. For option A, it is given to us energy was transferred from the object to the spring, which increased the maximum potential energy of the spring. This is true for ideal spring mass system. All the time this is happening, but this is not the reason why speed is decreasing. Maximum speed, we are talking about maximum speed, very important point. Maximum speed will not decrease when energy is transferred to potential energy. So energy will be transferred into potential energy, but when object will come back to equilibrium, maximum kinetic energy again will be the same if there is no friction. So it means this one is incorrect. The energy was transferred from the spring to the object, which decreased the maximum potential energy of the spring. This is also incorrect. As energy was transferred back and forth between the object and the spring, a greater average share of the energy became potential energy of the spring. Incorrect. The object spring system lost energy to its surrounding. So if maximum speed is lower, it means the system has lost energy to surroundings. So the answer for this question is D. So this is, you need to understand how energy change in spring mass system. So when object is at equilibrium, it has only kinetic energy, and when it is at extreme position, spring mass system has only EPE because the mass is not moving. So all the energy has been converted into EPE, and vice versa is also true. So this is how you need to understand. And if the maximum speed is decreasing, it means there are resistive forces, mean there is friction, there is air resistance. Due to those external resistive forces, system is losing energy. For question 25 and question 26, it is given to us a crate is on a horizontal frictionless surface. A force of magnitude F is exerted on the crate at an angle theta to the horizontal as shown in the figure above, causing the crate to slide to the right. The surface exerts a normal force of magnitude Fn on the crate. As the crate slides a distance d, it gains an amount of kinetic energy delta k. While F is kept constant, the angle theta is now doubled but is still less than 90 degrees. Assume the crate remains in contact with the surface. We need to find out how does the new normal force exerted on the crate compare to Fn. So we can simply draw another line here. So we increase the angle. So angle is double now. So simply we can draw like this. So in this case, it is given to us this angle is double. So this angle is equal to theta. We need to compare the new normal force with the old one. And so in both cases, we can write down first of all case 1, and we can also write down second case, case 2. For case 1, we need to understand mg. This is the force that is acting downwards. We can also draw the free body diagram. We have mg that is acting downwards, and there will be normal reaction force that is acting up. This is the n, and there is upward force that is F sine of theta. Means we can resolve this one into two components. So this is the force that is acting upwards. Normal reaction force is also acting upwards. So in this case, we have Fn. This is equal to F sine of theta. In the second case, also mg is equal to Fn nu. So this is Fn nu. Plus we have F sine of theta. So we can say this is theta 1 and this is theta 2. As in the question, it is given to us that theta 2 is greater than theta 1. It also means that sine of theta 2, this is greater than sine of theta 1. If sine of theta 2 is greater, means if this quantity, this increase, and this remains constant, it means overall this will increase. So overall this quantity will increase. So this one has to decrease because mg is the same. So f nu has to be lower than fn. So simply we can say in this case fn nu, this one has to be lower than fn because there is more upward force on the crate. So crate is pushing not as hard as before. So the answer for this question should be B. A is not correct because it's telling you is greater, this is telling you is less, so this is correct. This is telling you is equal, this is incorrect. The new normal force is greater or less than Fn depending on the value of theta. Value of theta is already given to us, that value of theta is greater than before. So this is also incorrect. So this is incorrect. This one is correct and this is also incorrect. Question 26 says, as the crate slides a distance d, how does the nu gain in kinetic energy compare to delta k? So this question is simply based on work energy theorem. So we can write down work done by the net force F net. This is equal to change in kinetic energy, and F net we can again rewrite F net times d. This one has to be equal to delta k. F net in this case is equal to F cosine of theta times d, and this is equal to delta k. As angle increase in this case, so we can write down angle increases. If theta increases, then cosine of theta will decrease because cosine of theta is equal to 1 is maximum when theta is equal to 0. So we can say cos of theta, this is maximum, this is equal to 1 when theta is equal to 0. When theta is equal to 0, cosine of theta is maximum. As angle increase, cosine of theta will decrease. As cosine of theta means this quantity decreases and f is the same, so it means overall this quantity means the horizontal component of the force will decrease, and d is the same. We are comparing for the same distance, so delta k has to be lower. So the answer for this question also has to be B. The nu gain is less than delta k. So the answer for this question is B. Question 27 says, a block on a level surface is attached to one end of a spring as shown in the figure above. The other end of the spring is attached to a wall. There is friction between the block and the surface. A person displaces the block from its equilibrium position and releases it. Which of the following shows the mechanical energy E as a function of time for the system that includes only the block and the system that includes the block and spring? Simple question, just based on conservation of energy, and we have discussed all those concepts in the previous questions. If you have understanding of those concepts, you can answer this question, but still there is a tricky part in this question. We need to understand that one. So in this case, you can also imagine if we displace this one to the left, it will be oscillating between these two extreme positions. So at this point, kinetic energy will be maximum. So we can say Ke will be maximum. At this point, Ke will be equal to 0, and at this point, Ke also will be equal to 0. And at this point, EPE will be maximum. So EPE will be maximum. So for this question, we need to find out mechanical energy as a function of time for the block only. So we can write down here E block. Energy of the block, the mechanical energy of the block, only equal to the kinetic energy. But energy of the block plus energy of the spring, this is equal to kinetic energy plus this is equal to EPE. So in this case, kinetic energy magnitude will increase when it is moving towards equilibrium. When it reach equilibrium, it will be maximum, and then it will start decreasing, and kinetic energy will be 0 when it is at extreme position. So it simply means that kinetic energy of the block, it will be oscillating. So this one will be oscillating between 0 and maximum value, and maximum value each time will go down because there is friction, so there's loss of energy, so it will be oscillating, and K max always will decrease, so K max will keep on decreasing. So these 2 points we need to understand about the block. So how about energy of the block and spring? So this is the total energy of the system. Total energy of the system will not reach zero and then increase, mean it will not oscillate, it will just keep on decreasing due to resistive forces. Finally, when this energy becomes zero, it means system will just stop, so it will not oscillate, it will not oscillate. This is the main concept you need to understand. Total energy will not oscillate, total energy will just decrease exponentially, so we can say decreases exponentially, but it will not oscillate, decreases exponentially. So these are the points you need to understand. If these points are clear to you, now we can find the answer. Total energy will not oscillate, so it means this is incorrect. Total energy remains constant, this is incorrect. Decreases exponentially, this can be possible. This is telling us energy of the block remains constant, energy of the block also will decrease and also it will oscillate, so this is not correct. So answer is D for this question. So kinetic energy is oscillating, you can see, but the peak is always lower than before, means system is losing energy, and total energy of the system just keep on decreasing exponentially. So the answer for this question is D. A beautiful question, little bit tricky one, but if you have some understanding of conservation of energy for spring mass system, is very easy to figure out. Question 28 says a transverse wave is traveling on a string. The graph above shows position as a function of time for a point on the string. If the frequency of the wave is doubled, what is the new average speed of the point? So in this case we are talking about speed, so simply we can say speed is equal to distance traveled by the point in a certain period of time, means distance divided by time. But for this question it is given to us that frequency is double. If frequency is double, it means time period has to be half, so we can say f nu, as f nu is equal to 2f, so it means the time period, so this has to be t by 2, means t nu, this is half, so we can say t nu, this one has to be half, t by 2. So time period simply you can read from here, we have that is equal to 0.5 divided by 2, so the new time period is equal to 0.25. So we can write on here time period that is equal to 0.25 second, and in one time period this particle, the total distance traveled by the particle in one time period. So particle, let's say it start from here, it will go up, it will travel 0.6 meters, 0.6 meters, and then this particle will come down and it will travel again 0.6 meters, then this particle will go down, it will travel again 0.6 meters, and then finally it will come back to equilibrium position again, so it will travel extra 0.6 meters. So total distance traveled in this case is 4 times 0.6 meters, and this is equal to 2.4 meters divided by, we have 0.25 second. So the final answer, means the final value of the speed, this will be equal to 9.6 meters per second. So the answer for this question is D. A beautiful question, very nice question about wave. How to calculate speed of the particle. Question 29 says Alan and his friend are on opposite sides of a large room. When Alan says something to his friend does not hear him, so Alan repeats the message louder. Louder is very important, and his friend now hears it. Which of the following could be different about the second sound wave compared to the first that allows his friend to hear it? So in this case it is given to us the second sound is louder, medium is the same, so speed is the same. As the second sound is louder, so we can say loudness is linked with amplitude. If the sound is louder, it means amplitude of the sound is greater, or we can say maximum displacement is greater. So the second sound has higher or greater amplitude, or we can say greater displacement. As this is louder, so amplitude of the second sound wave is higher. Now if you look at given options, for option A, it is given to us the second wave travels to his friend more quickly, means speed is greater. Speed depends on the medium, and it also depends on type of the wave. If type of wave is the same, medium is the same, speed is the same. So this is incorrect. The second wave reflects more of the walls. In this case, walls material is not changing. Walls material is the same, and geometry of the walls is also the same. Geometry of the room is also the same. It means reflection is also the same. So this is also incorrect. The air molecules disturbed by the second wave undergoes a greater displacement from the equilibrium, means higher amplitude. So this one is correct. Question 30 says two strings differing only in length are attached to the same oscillator as shown in the figure above. Both are fixed at the other end and are under the same tension. The oscillator creates a transverse wave and is adjusted to the lowest frequency that creates a standing wave on the shorter string. Which of the following explains why there will not be a standing wave on the longer string? If you look at given options, for option A it is given to us the waves travel at slightly different speeds on the two strings. Speed of wave on a string depends on two factors. One is tension. In this case, tension is the same. It is given to us, tension is the same, so this factor is the same. And second is the linear density. If strings are the same, it means they have the same properties as well. So linear density is also the same. So the speed in these two strings will be the same. In the speed of the waves on these two strings will be the same. So this option is incorrect. Option B, an oscillator frequency that results in a standing wave on a string of one length cannot result in a standing wave on a string with a different length. This option is also incorrect, because one frequency, if we can create standing wave on one string, a different harmonic can produce a standing wave, different harmonic. So different harmonic can create a standing wave on other string if lengths of these two strings are in appropriate ratio, then it is possible. So this is also incorrect. The amplitude of the wave does not match the boundary conditions for strings of different length at the same time. This is also not correct, because amplitude only affects the amplitude of resultant standing wave or height of resultant standing wave. So this option is also incorrect. Option D, the wavelength associated with the given frequency does not match the boundary condition set by the length of the longer string. So this option is correct. So that's the reason stationary wave will not produce, because they are not in appropriate ratio. If they have appropriate ratio, then there will be standing wave. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions for AP Physics 1. In the last few videos, we have discussed a lot of questions about AP Physics 1 exam. And in today's video, we will discuss more questions, and we will discuss these questions in detail so you can improve your conceptual understanding of these topics, and also you can have better understanding of these questions. Let's study together. Let's improve together. Question 31 says the figure above shows the net force exerted on an object as a function of the position of the object. The object starts from rest at position x is equal to 0 meters and acquires a speed of 3.0 meters per second after traveling a distance of 0.090 meters. What is the mass of the object? So in this case, it is given to us, we have mass m. So imagine that mass of this object is capital M. We need to find out this mass, and net force is acting on this object. So we can also imagine net force is capital F, and in this case it is given to us object is initially at x is equal to 0 meters, and we apply net force on this object for a distance of x is equal to 0.090 meters, and we need to find out what is mass of this object. So we need to find out mass of this object. So in this case, we need to understand, as net force is acting on the object, this net force will increase the kinetic energy of the object. So simply we can say, in this case, work done by F means work done by net force. This will be equal to change in kinetic energy of the object. That in this case, the initial kinetic energy of the object is equal to 0. So simply we can say this is 1/2 mv square minus, as initial kinetic energy is equal to 0. So simply we can say this one is equal to 0. So in this case, simply we can write down F net time distance t. This is equal to 1/2 mv square, and we need to calculate in this case value of m, and the final speed is given to us. We have value of v, that is equal to 3.0 meters per second. So we have the final speed. Fd is the work done, and we have force on y-axis and position is given to us on x-axis. So area under this line, this area is representing work done. So simply we can say this area is equal to work done. So this is work done. So in this case, area is representing work done, and area in this case is equal to 1/2, because this is a triangle, time force time the base 0.090, and this is equal to 1/2 mv square. So we can write down value of m, value of v, because value of v is given to us, so we can replace with its value. Value of v is given, that is equal to 3 meters per second per second. So we can also cancel in this case 1/2 with 1/2. Now simply we need to find out m, so we can write down 3 times 0.090, and this is divided by 3 square. So this is divided by 3 square. So we can cancel this 3 with this. So simply we left with 0.090 divided by 3. So the final answer should be equal to 0.030 kgs. So this is mass of the object. So you can see the beauty of physics, how we have calculated mass of the object by simply looking at motion of the object. So the answer for this question is B. Question 32 says two identical carts are free to move along a straight frictionless track. At time t1, cart x is moving at 2.0 meters per second when it collides and sticks to cart y, which is initially at rest. Which of the following graphs best shows the velocity of cart x before and after the collision? A beautiful question just based on conservation momentum. In order to answer this question, simply we can sketch. First of all, we can imagine this is cart x, and this one is moving to the right with initial velocity ux, and its initial velocity is equal to 2.0 meters per second, and cart y is at rest. So this is cart y, this is at rest. and these two cards, they are identical, and after collision these two cards, they stick together. So simply we can draw here, they stick together. Let's say this is X and this one is Y. So in this case we need to understand the initial momentum is to the right, so this is equal to 0. As initial momentum is to the right, we can take to the right as positive. So the final momentum also has to be to the right, because in this case there is no net external force acting on the system, so momentum has to be conserved. So these two cars, they have to move to the right. Let's say the velocity is v. Now simply we can use conservation momentum. Initial momentum in this case has to be equal to final momentum. We can also imagine mass of each card is m, because these are identical cards, so they have the same mass. So this is mass m, this is also mass m. So momentum of first card we can write on, this is m times 2 plus 0, and final momentum we have m plus m, and they're moving with velocity v, and we can calculate value of v. So from here we can write on v will be equal to 2m divided by 2m. So this is equal to 1 meters per second. So this is velocity of x, and also this is velocity of y. So we have to look only at velocity of card x before and after. Before, we can write down velocity of card x before. Velocity of card x ux, this is equal to 2 meters per second, and after collision the velocity of card x decreases to 1 meters per second, but it is still positive, 1 meter per second, still positive. So the first one is not possible. This is telling us that the speed is not changing, and this is telling us speed decrease but less than 1, mean decreases by less than 1. So this option is also incorrect. Final velocity has to be 1. This one is correct because this is initial velocity and this is final, and this is 1. So this is our answer. This is incorrect because this is telling us velocity after collision is 0 meters per second. So this is incorrect. So the answer for this question is C. This is how you can approach this type of problems. A beautiful question. If you look at this one carefully, it will help you to understand conservation of momentum. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions for AP Physics 1. In this lesson, we will discuss these questions in detail so you can improve your conceptual understanding of these topics, and also you can have better understanding of these questions. Let's study together. Let's improve together. Question says, a spaceship and its shuttle pod are traveling to the right in a straight line with speed v as shown in the top figure above. The mass of the pod is m and the mass of the spaceship is 6m. The pod is launched and afterward the pod is moving to the right with speed vp, and the spaceship is moving to the right with speed vf, where vf is greater than v. As shown in the bottom figure, which of the following is true of the speed vc of the center of mass of the system after the pod is launched? So in this case, we need to understand when velocity of center of mass of system will change. Velocity of center of mass only changes if there is net external force acting on the system. As in this case, there is no net external force acting on the system before and after launching the pod. So in this case, velocity of center of mass has to remain constant, and velocity of center of mass before launching was equal to v, because spaceship is moving with that speed. And velocity of center of mass after launching pod also has to be equal to v. So it simply means that velocity of center of mass is equal to v. So the answer for this question has to be D. So D is the answer. So you need to understand delta VC is equal to 0. if no net external force acting on the system. If no net external force acting on the system. So this is the point you need to understand. Acting on the system. So this is the key concept which you need to understand. Acting on the system. Delta VC is equal to 0 means velocity of center of mass does not change if no net external force is acting on the system. Question 34 says the diagram above shows a top view of a child of mass capital M on a circular platform of mass 5m that is rotating counterclockwise. Assume the platform rotates without friction. Which of the following describes an action by the child that will result in an increase in the total angular momentum of the child platform system? So for this question, we need to understand is there any net external force acting on the system or not? As in this case, it is given to us that there is no friction. So it means that there is no net external force acting on the system. So simply we can say in this case, F net on the system is equal to 0. So we are talking here for the system. So for the system, F net is equal to 0. If F net is equal to 0, it means that tau net is also equal to 0. If tau net is equal to 0, it also means that change in angular momentum is also 0. So we can say delta L in this case is also equal to 0. Means angular momentum remains constant. So in this case, if the child is moving towards center, our child is moving away from the center, our child is moving along the circle, concentric circle. In all these cases, total angular momentum of the system will not change, but the momentum of the child will change, or momentum of the platform will change, but total angular momentum of the system will not change, because in this case there is no net external force acting on the system. So answer for this question has to be D. None of the actions described will change the total angular momentum of the child platform system. As there is no net force, so there is no net torque. If there is no net torque, it means that angular momentum of the system remains constant. Question 35 says a train is traveling east with constant speed Vt. Two identical spheres are rolling on the floor of one train car in the frame of reference of the train. In the frame of reference of the train, the spheres are moving directly towards each other at one instant with same speed Vp. Means these two spheres, they have the same speed Vp. So simply we can label this one, they have same speed Vp. And the speed of the train is given to us, that is Vt. So this is speed of the train with the same speed Vp parallel to the train's motion as shown in the figure above. What is the velocity of the center of mass of the spheres in the frame of reference of the train and in the frame of reference of a person standing at rest alongside the train? So first of all, we need to understand in frame of reference of train. So we can write down in frame of reference of train, reference of train, frame of reference of train. So as in this case, these two spheres are moving towards each other with constant speed and they're moving opposite, so the center of mass will stay at rest. So center of mass, we can say velocity of center of mass in this case will be equal to 0 because they are moving with constant speed in opposite direction. So if the center of mass is at the center, we can also label here is here, so center of mass will stay here, so its velocity will be equal to 0. Now we can try to understand this one in frame of reference of person, in frame of reference of person standing outside of the train, frame of reference of person standing outside of the train. According to that person, as velocity of center of mass of the sphere in frame of reference of train is equal to 0, so the velocity of sphere, center of mass of sphere in frame of reference of person has to be equal to the velocity of the train. So in frame of reference of person, velocity of center of mass will be equal to the velocity of the train to the east. Velocity of the train means train is moving to the east, so it has to be equal to that. So we can also say in this case, velocity of center of mass with respect to ground with respect to person, or simply we can say this one has to be equal to velocity of center of mass with respect to train plus velocity of train, we can say velocity of train with respect to the ground, velocity of train with respect to ground. So in this case, velocity of center of mass with respect to train is equal to 0, and velocity of train with respect to ground, velocity of train with respect to ground in this case is equal to Vt. So this is velocity of train. So in this case, velocity of center of mass with respect to ground, this is simply equal to Vt. So velocity of is equal to Vt, and this is to the east. So the answer for this question has to be B, 0 with respect to train and Vt with respect to person. So the answer for this one is B. Question 36 says a satellite that is a spinning cylinder has initial rotational inertia I naught and angular velocity omega naught. Solar panels unfold from the satellite and are extended outwards. The satellite then has rotational inertia if is equal to a I naught and angular velocity omega f is equal to b omega naught, where a and b are constants. Which of the following is true about constants a and b? So in this case, you can simply imagine that first of all, satellite is like a fist and then it is extended. As satellite is extended, so more mass is away from the center, so its moment of inertia increases. So we can say if in this case increases, if increases, and if is greater than I naught. As if is greater than I naught and if is equal to a times I naught, so a has to be greater than 1. So a has to be greater than 1. So this is one thing we can understand. And the second thing we need to understand, as in this case there is no net external force acting on the satellite, so angular momentum remains constant. So delta L is equal to 0. It simply means that I naught omega naught angular momentum, delta L is representing angular momentum, so there is no change in angular momentum. So we can say I naught omega naught, this is equal to if omega f. As in this case if has increased, so omega f has to decrease to keep angular momentum constant. So it simply means that omega f in this case is smaller than omega naught. So we can say in this case, as omega f, this is equal to b times omega naught, so b has to be lower than 1. So this is b has to be lower than 1 because omega f is lower than omega naught. So a has to be greater than 1 and b has to be lower than 1. So the answer for this question has to be B. A has to be greater than 1, B has to be lower than 1. So the answer for this question is B. Question 37 says, when the circuit shown above is set up, the potential difference across the battery is 3.0 volts. By how much will the magnitude of potential difference across R2 changes when R3 is removed and its branch is left open? So first of all, in this case, we will try to find out what is value of potential difference across R2 when R3 is connected. So we can simply say this one is V1. This is V1. And then we will try to find out when this branch is disconnected, what is value of V1 prime. We can redraw this circuit. So first of all, we can redraw this circuit. So we have one cell, this is 3.0 volts, and we have one resistor here. As these two resistors, they are connected in parallel. As they are connected in parallel, so the total resistance, R total, of these two resistors connected in parallel simply will be equal to R2 multiplied by R3 divided by R2 plus R3. As in this case, R2 is equal to 100 ohms, R3 is also equal to 100 ohms. So here we have 100 plus 100. So in this case, simply we have, this is 100 multiplied by 100 and divided by 200. So simply we can say this is 100 multiplied by 100, and this is 2 multiplied by 100. So 100 and it will be cancelled, and total resistance of these two resistors in parallel, this is equal to 50 ohms. So this is equal to 50 ohms. We no need to do this whole process. Simply you need to understand, if resistors are identical and they are connected in parallel, then total resistance simply you can calculate. You can take the resistance of one resistor and you can simply divide by number of resistors. As in this case, resistance of one resistor is 100 and we have two resistors in parallel, so the total resistance in this case of these two resistors is equal to 50 ohms. So this is how you can calculate, but you can also use this method. So we can replace those two resistors with one single resistor. So this one is 100 ohms, this is R1, and this is over R total, we can say RT, and this one is equal to 50 ohms. So we have to find out what is value of V across this one, because the PD across R3 and R2 is the same. So if we need to find out V across this one, so we can say this is V1. V1 has to be equal to the resistance of this resistor, that is equal to 50 divided by total resistance of these resistors in series. This formula you can only use if the resistors are connected in series. So we have the resistance of this resistor divided by total resistance, means we have 50 plus 100, and we have to multiply this one with potential difference across these resistors in series, that is equal to 3 volts. So this is 3.0 volts. Now if we simplify this one, we have here 50 and this is divided by 150. I'm just writing these things in detail, but if you are very clear about this one, this question can be done in just one step. So from here we can cancel, so we will get here, this is equal to 3 and we will cancel, so we will get 1. So this is 1.0 volts, so value of V1. So we have got value of V1 when these three resistors are working properly in the circuit. Now we have to remove this 1, and so we can redraw our circuit. So we can redraw circuit. So simply we have, this is 3 volts battery and we have one resistor, that is R1, and its resistance is equal to 100 ohms, and the second resistor we have R2 and its resistance is also equal to 100 ohms. This is 3.0 volts. 3.0 volts. As two resistors, they have the same resistance and they are connected in series. It means PD across this one has to be equal to, we can say this is V1 prime. So this one has to be equal to 1.5 volts. 1.5 volts, we can say V1 prime. This has to be equal to 1.5 volts. Now simply you can say the potential difference across R2 has been increased by 0.5 volts, so it has been increased by 0.5 volts. So this delta V has been increased by 0.5 volts. So the answer for this question has to be the magnitude of potential difference decreases by, this is wrong, doesn't change, this is wrong, this is telling us increases by 0.5 volts. So the answer for this one has to be C. So this is how you can approach, but if you wanna use this formula to calculate, you can also use the formula. You can say in this case V1 prime, this one has to be equal to the resistance of this resistor, that is equal to 100, divided by total resistance, that is equal to 200, multiply by the resistance across these resistors, potential difference across these resistors, that is equal to 3.0. Now if we solve this one, we will get this is 1.5 volts. So this is also, you can use this formula, you can calculate. So the answer for this question has to be C. Very straightforward question. I just did this one in detail, but if you have clear understanding of circuits, you can just look at the question and you can find out the answer. Question 38 says two wave pulses are propagating along a straight line toward each other as shown above. Which of the following is the resultant when the centers of the pulses align? Centers of the pulses align. So in this case, when these two waves meet, what is the resultant wave? So for that purpose, we can simply first of all redraw these two pulses. So we have one pulse here, so this is one pulse where they align, their centers align. So we can draw the second pulse here. So we can draw the second pulse. So this one is the second pulse. Now simply we need to add these two pulses. If you look at this point, the red one, it has zero displacement, and blue one, this one has this much displacement. So we can see this has positive displacement. So this is the positive displacement. Now if you look at the center point, we can use two different colors. This one has negative displacement, so this is negative, and the top one, this has positive displacement, but they have same magnitude and they are in opposite direction. So the resultant displacement has to be 0. So this point has to be at 0. We can also take another point. Let's say we take one point here. So we can draw the arrow from the equilibrium. So this is negative displacement, and we have the positive displacement, that is here. So in this case, positive displacement is greater, so it means that the resultant displacement is somewhat here at this point. The same will be true here. It will be the same process, it will be here. Now simply we need to connect these points. So we have displacement here, so it will look like this, and at this point also displacement is positive. At this point also displacement is positive. Simply you need to add these arrows, and here it will come to this point. So this is the resultant. So red one is the resultant. Now we can clear rest of them. So we can clear them. So here if we clear, so this will be the final shape. This will look like M. So the answer for this question has to be C. Simply you need to add like a vectors, and this will be the final shape. So the answer for this question is C. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions for AP Physics 1 exam. In this lesson, we will discuss these questions in detail so you can improve your conceptual understanding of these topics, and also you can have better understanding of these questions. Let's study together. Let's improve together. Question 39 says a person holds a 4.0 kg block at position A shown above on the left in contact with an uncompressed vertical spring with a spring constant of 500 newtons per meter. The person gently lowers the block from rest at position A to rest at position B. Which of the following describes the change in energy of the block spring earth system as a result of the block being lowered. So we need to calculate in this case the change in energy. So when the block is at this point, spring is not compressed, so only energy this block has, this system has, that is GPE. And when the block is at this point, it has GPE, so we can say it has GPE and also it has EPE. But in this case, the smart way is, if we take this line as our reference point, if we take this one as our reference point, so we can say GPE at this point is equal to 0. So it has GPE here, but EPE at that point is equal to 0 because spring is not compressed. So in this case, we can calculate loss in GPE. First of all, we can write down loss in GPE. Loss in GPE will be equal to mg delta H, and delta H in this case is equal to 10 centimeters. So we have 10 centimeters, 30 minus 20, and this one is equal to 0.1 meters. Now simply we can plug in values. In this case, mass of the block is given, that is equal to 4.0 kgs, and we have value of G, that is 10 newtons per kg, and delta H is given, that is equal to 0.1 meter. If we simply multiply this one, we will get 4.0 joules. So this is the value of GPE at this point. So this is 4.0 joules. We can also calculate gain in EPE. Gain in EPE. Gain in EPE, this will be equal to 1/2 K times delta X square. But delta X square in this case means how much spring has been compressed, that is equal to delta H. So we can say this is equal to 1/2 K times delta H square. This much spring has been compressed. So we have values of K, that is equal to 500, and value of H we have, that is equal to 0.1 square. And if we solve this one, we will get this is equal to 2.5 joules. So now we need to calculate in this case loss in energy. So I will be writing here loss in energy, or we can say change in energy. Loss in energy of the system, or we can say change in energy. So the loss in energy in this case is equal to 4.0 minus, we have 2.5 joules. 2.5 joules. So we will get this is equal to 1.5 joules. Means energy has been decreased by this much approximately. So if you look at given option, the energy decreases by approximately 1.5 joules. This is right. So the answer for this question is A. This one is incorrect. This is also incorrect. Energy of the system does not change. This is also incorrect. So the answer for this question is A. This question is simply based on conservation of energy. Question 40 says the stocks of boxes shown in the figure above are inside an elevator that is moving upward. The masses of the boxes are given in terms of the mass capital M of the lightest box. How does the magnitude of the force exerted by the top box on the bottom box compares with the magnitude of the force exerted by the bottom box on the top box for each of the stocks? So in this case, first of all, we can simply imagine we have a block M. Let's say this is block M, and we also have another block that has also mass capital M, as given in figure 1, as given in this arrangement. And so in this case, we can, this is our top box, we can say this is top 1, and the lower one, this is the bottom box. Top box will push on the bottom box, so this one is our bottom box. It will be pushed by top box by force mg. And now if we draw the top box, here we can draw the top box, so it also has mass m, and the bottom box will push on this one upwards. with the same magnitude of force. So this will push this one upward with the same magnitude of force, that is mg. Because these forces are action and reaction forces, they are the same type of forces, they are acting on two different objects and they are acting in opposite directions. Now simply we can say these are Newton's third law of air forces. Newton's third law of air forces. Newton third law air forces. So these are Newton third law air forces. Now if you look at this block, maybe this one is a little bit complicated one. So for this block we have this arrangement. We have 4m mass, so this is 4m, and we have here 2m, so 2m is placed at the bottom. So in this case the force on the bottom box, it is pushed by the top box by force 4mg. So this is 2m, and the force on the 4m box, force on this one will be equal to 4mg as well, because these are action and reaction forces. These are same type of forces acting on two different objects but acting in opposite directions. So each box will experience, so this one, the force on this one is 4mg, the force on this one in the upward direction, if I draw here, this will be 2mg, and force on the bottom box, force on this one will be, here I can draw this will be 2mg as well, and the force on this one upwards will be 2mg, this one will be 2mg, and the force on this, the bottom box, this one also will be 2mg. So this is how you need to understand this problem. In this case, these forces are action and reaction forces and they form Newton's third law of air. So that's the reason these forces are equal in magnitude and opposite in directions. So the answer for this question, now we need to figure out the answer. For option A, it is given to us the two magnitudes are always equal in each of the stocks. Yes. So the answer for this question is A. Question 41 says, assume the elevator is moving at constant speed and consider the bottom box in the stock that has two boxes of mass 2m. Means we have to consider this stock. Let F floor be the force exerted by the floor on the box, Fg be the force exerted by gravity on the box, and F box be the force exerted by the top box on the bottom box. Which of the following best represents the forces exerted on the bottom box? First of all, we need to understand it is given to us that box is moving at constant speed. Constant speed simply means that net force is equal to 0. So very important point. So net force is equal to 0. So the forces on the bottom box are balanced. Now if we draw this arrangement again, mean this stock again, so we can draw these two boxes and we will focus on the bottom box only. This is 2m and here we have the ground. So this one is the ground. This is the ground. So in this case, first of all, the force acting on this box is the force of gravity. We can say this is Fg and this is equal to 2mg. And now there is force on the bottom box by the top box, and that force is F box, and this force also is equal to 2mg. As these two forces are acting down, there must be force from the floor in the upward direction. So we can say this is F floor, and F floor has to be equal to F box plus Fg, because this block is moving at constant speed. So if you have this understanding, we can redraw the diagram. So we can say F floor is pushing this box in upward direction, and there is a force on this one, that is force of gravity, that is acting down, and also there is force by the top box that is also acting in downward direction. So this is our free body diagram. These are the forces acting on the bottom box. So option 1, this is incorrect because force by the box is missing. This is right, but this one is also incorrect because also the force by gravity is missing in this case. So this is also incorrect. Force by the floor upward, force by gravity down, force by box down, top box. So this is our answer, and this one is incorrect. Gravity is down, force by the box is down, not up. So this one is incorrect. So the answer for this question is C. This is how you can figure out. Question 42 says, assume the elevator has upward acceleration A and consider the stock that has two boxes of mass capital M. What is the magnitude of the force exerted on the top box by the bottom box on the top box? So we can draw this arrangement again. So we have two boxes. So we have these two boxes. Mass of this box is capital M and mass of this one is also capital M. For this question, it is given to us elevator is moving upward with acceleration A. So it means acceleration of this box is also A. So we can say the net force on the top box, F net, this one has to be equal to M times A, and F net has to be in the upward direction. Now if we consider the forces acting on this box, one is the gravity that is acting down, so this is equal to mg, and there is a force on the top box by the bottom box. This force is in upward direction. We can say this force is Fn, normal reaction force, pushing force by this box. So in this case, F net, this is equal to ma, and this one has to be equal to Fn minus mg, but we need to find out what is value of Fn. So Fn in this case, simply we can write down this one has to be equal to ma plus mg. So if we take m common from here, we can say this is a plus g. So this is the force exerted on the top box by the bottom box. So it is accelerating. That's the reason Fn is equal to m times a plus g. So the answer for this question is D. Question 43 says, a researcher is analyzing data from a high energy particle collision. The result of the analysis gives a value of 8.8 times 10 to minus 19 coulombs plus minus 0.1 times 10 to minus 19 coulombs for the charge of one of the emitted particles. Should the researcher accept the value? So in this case, it is given to us that charge on the particle is equal to 8.8 times 10 to minus 19 coulombs plus minus 0.1 times 10 to minus 19 coulombs. It simply means that this charge can be 8.7 times 10 to minus 19 coulombs, or this charge can be 8.9 times 10 to minus 19 coulombs. So we need to understand charge on any particle has to be integer multiple of the charge on single electron, means n times e. So n here, this one has to be the integer, and e is the charge on single electron. So this is the elementary charge, the charge on single electron. N has to be integer number, so it has to be integer. It has to be integer, means n can be 1, it can be 2, it can be 3, 4, 5, and so on. But n cannot be 0.5, n cannot be 1.5, n cannot be 2.5. So this is incorrect. So in this case, if you look at this one, let's say we have q, this one can be 5 times, this number can be 5, so we have 1.6 times 10 to minus 19 coulombs, so this will be equal to 8.0 times 10 to minus 19 coulombs, RQ can be 6, N can be 6, and this is 1.6 times 10 to minus 19 coulombs. So in this case, possible charge can be 9.6 times 10 to minus 19 coulombs. As this is not 8.0 and this is also not 9.6, it is between these values, so it means this charge is not possible. This is not possible, this is also not possible. Yes, it is a perfectly acceptable value. No, it is incorrect. No, because the value is much bigger than elementary charge. This is right, but this one is wrong. So this option is also incorrect. No, because the value is not an integer multiple of the elementary charge. This statement is correct, and this statement is also incorrect. So the answer for this question is C. Question 44 says the current through the 3 ohms resistor in the circuit shown above is most nearly. Simply we need to find out how much current is passing through this resistor. So value of I we need to find out in this case. So the best way to answer this problem is, if you look at this part of the circuit, we have these 2 resistors, they are connected in parallel. So we can find out the total resistance of these 2 resistors. So we can simply write down RT. RT in this case has to be equal to 3 times 6 divided by 3 plus 6. So we have 18, this is divided by 9, so this is equal to 2 ohms. So we can redraw our circuit. So we have our circuit, we have 1 ohm resistor, and then we have 2 ohm resistor. So we have 12 volts battery. This resistor is 1 ohm and this one is 2 ohm. So we can find out the PD across this 2 ohm resistor. So let's say we connect our voltmeter here. Let's say this is our voltmeter. So the value of V we can find out. Value of V will be equal to 2 divided by, means the resistance of this resistor divided by the total resistance. We have 1 plus 2 multiplied by EMF of the battery. So we have 12 volts. So if we solve this one, we will get this is 2 divided by 3 multiplied by 12. So in this case we will get value of V, that is equal to 8 volts. So this is value of V. Value of V. So in this case we need to understand the PD across this one. PD across this one has to be equal to 8 volts, and PD across this one also has to be equal to 8 volts. So this also has to be equal to 8 volts. So we have the PD across this one and we have resistance of this resistor, so we can find out value of current. So PD across this one is 8 volts divided by 3. So we will get this is about 2.7 amps. 2.7. So you can also check this. We have 8, this is divided by 3. So if we solve this one, we'll get 2.6. So it's very close to 2.7 value. So the answer for this question has to be B. So B is the right answer. So this is how you can figure out. Question 45 says a student wants to determine the speed of sound at an elevation of 1 mile. To do this, the student performs an experiment to determine the resonance frequencies of tube that is closed at one end. The student takes measurements every day for a week and gets different results on different days. Different results means student get different values of speeds at different days. Which of the following experiments would help the student determine the reason for the different results? Means the reason for different results. What kind of experiment student can arrange to find out why his results are different? For that purpose, we need to understand the speed of sound. It depends on temperature. Speed of sound. It depends on temperature. Depends on temperature. Depends on temperature. And temperature, different days, temperature can be different. Temperature can be different on different days. So in this case, temperature is uncontrolled variable. Student is not controlling temperature. So temperature is uncontrolled variable. So due to change in temperature, speed of sound is different, and that's the reason his results are different. So student needs to control temperature, and he can verify this one by doing experiment for a certain period of time on certain days when temperature is same, means temperature is 10 degrees Celsius or temperature is 20 degrees Celsius, and he can repeat the same experiment for same number of days when temperature, let's say, is 40 degrees Celsius, and then he can compare the results. If the results are different, it means temperature is affecting the results. So temperature is the reason behind different results. So simply in this case, student needs to control temperature. So if you look at given options, for option A it is given to us repeating the experiment on several 10 degrees Celsius days and 20 degrees Celsius days. So if student do experiment for certain days when temperature is 10 degrees Celsius and for certain days when temperature is 20 degrees Celsius, student can compare the results and student can find the reason behind different results. So option A is correct. Option B is incorrect. Longer tube doesn't affect. This is incorrect. Experiment using a wider range of frequencies, it will not give the reason of different results. So this is also incorrect. Repeating the original experiment for additional week, it will also not give the reason behind different results. So the answer for this question is A. So simply student in this case has to control temperature because speed of sound depends on temperature. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions for AP Physics 1 exam. In the last few videos, we have discussed from question 1 to question 45. And today's lesson, we will start from question 46 and we will discuss all remaining questions from this paper. As always we will discuss these questions in detail so you can improve your conceptual understanding of these concepts and also you can have better understanding of these questions. Let's study together, let's improve together. Question 46 says a uniform plank is placed with a pivot at its center. A block is placed on the plank to the left of the pivot as shown in the figure above. A student is asked to place a second block of greater mass on the plank so it will balance when horizontal. Which of the following quantities are needed to determine where the second block should be placed? Select two answers. So in this case simply we have to balance this block and we need to select two answers. We can imagine the mass of this block, let's say, is capital M and the mass of this block is small m. In order to balance this block, we have to place this greater mass closer to the pivot. So it has to be here. For this purpose, simply we need to understand equilibrium. So we can write down in equilibrium. So when this block is in equilibrium, clockwise moment. So we can say moment clockwise moment has to be equal to anti-clockwise moment. These two moments has to be equal anti-clockwise moment. So we can say CCW, counter-clockwise moment. Due to this block, moment will be clockwise, so this will be CW clockwise, and due to this one it will be anti-clockwise CCW, and these two moments has to be equal. Clockwise moment we have, this is capital M G and the distance from the pivot, so we can say this distance is D1 and we can say this distance from the pivot, let's say this is D2 times D1. This one has to be equal to small mg times D2. So we need to consider in this case two things we have to consider. So G will be cancelled. So we have to consider in this case mass of each block, to balance this block. Mass of each block we have to consider, means we have to consider this mass, we also have to consider this mass of each block we have to consider. And also we have to consider the distance from the pivot, distance of each block from the pivot. Distance, actually proper way to say this one, perpendicular distance. So this is perpendicular distance of each block from pivot. So these 2 points we have to consider. Now if you look at given options, it is given to us mass of the plank. Mass of the plank doesn't matter. It is lighter, it is heavier, it doesn't matter, because this is uniform plank and its center is placed at the pivot, so its mass doesn't matter. Mass of each block we have to consider. Yes, this option is correct. The length of the plank doesn't matter, so this option is incorrect. The distance from the pivot to the left block, yes, we have to consider, so this one is correct. So answer is B and D. Two options we have to choose from the given option, so the answer is B and D. Question 47 says a block is held at rest against a wall by a force of magnitude capital F exerted at an angle theta from the horizontal, as shown in the figure above. Let F sub G be the gravitational force exerted by Earth on the block. Fn be the normal force exerted by the wall on the block, and F sub F be the frictional force exerted by the wall on the block. Which of the following statements about the magnitudes of the forces on the block must be true? Select two answers. We have to select two answers, and this question is simply about forces, the forces acting on the block. One force is given to us, capital F. This force is acting on the block, and we can resolve this force into its two components. So one component is acting vertically upwards and one is acting to the right. So this has two components, and this component of the force, we can say upward, this has to be F sine of theta, because this is opposite to the angle, and with angle this component has to be F cosine of theta. We can also draw the force of gravity that is acting on the block. We can say this one is Fg, and the normal reaction force acting on the block by the wall. This force is pushing the block with this force to the right, and the block will push the wall with the same force, and the wall will push the block to the left. So there is a force on the block by the wall, and this is Fn. And the frictional force can be upwards, frictional force can be downwards. If the block has tendency to go up, frictional force will be down. If block has tendency to go down, frictional force will be up. So frictional force we can simply write down, it can be up or it can be down. So simply we can write down this is plus minus F. So if we look at forces along horizontal, so we can say along horizontal. So simply we can say along horizontal. So there are two forces. So in this case simply we can say Fn has to be equal to F cosine of theta. These two forces has to balance each other, so the block will not move horizontally. And we can also resolve forces along vertical. So along vertical we have Fg, this is acting down, F sine of theta, this is acting up. So we have F sine of theta, this is acting up, and this one has to be equal to Fg plus minus force of friction. If block has tendency to go up, friction will be down. If block has tendency to go down, friction will be up. So it depends on which way block has tendency to move. So this is how forces are balanced along vertical, and this is how forces are balanced along horizontal. If we have understanding of these points, now we can choose the answer. If you look at first one, it is given to us F is equal to Fg sine theta. So this is telling us that Fg is equal to F sine of theta, but it is missing the frictional force. This part is missing, so this one is incorrect. F cosine of theta is equal to Fn. Yes, F cosine theta is equal to Fn. So this one is correct. This option is correct. F sine of theta is equal to Fg plus minus F. This is. So C is also correct. And D is incorrect. So this is incorrect. So the answer for this question is B and C. We have to select two answers. So this is the answer. Beautiful question on forces. Question 48 says some students have determined the gravitational mass of an object and want to compare it to the object's inertial mass. Procedures that would allow them to accomplish this include which of the following? Select two answers. Mean which procedures can be used to determine inertial mass of the object. If you look at option A, it is given to us hanging the object vertically from a spring scale and recording the scale reading. First of all, this is depending on gravitational field, and this will give us gravitational mass. So this is depending on gravitational field, and in this case we will get gravitational mass. So this option is incorrect. If you look at option B, it is given to us placing the object on one side of a double band balance, adding objects of non-masses to the other side until the masses are balanced, and recording the amount of mass added. This also depends on gravitational field, and it will help us to find the gravitational mass because it is relying on gravitational field, and it will give us gravitational mass. So option B is also incorrect. Now if you look at option C, it is given to us attaching the object to a spring of non-spring constant, allowing it to oscillate horizontally on a nearly frictionless surface and measure the period. So in this case we can determine the period, and spring is oscillating on a horizontal frictionless surface. So it is oscillating, mass is oscillating on horizontal frictionless surface. So in this case we can determine the time period. Time period T will be equal to 2 pi m over k. So if we have time period and if we have the k, we can find the inertial mass. So this option is correct. So we can determine inertial mass. Now if you look at option D, so this one is correct. Attaching the object to a force sensor, using the sensor to pull the object across a nearly frictionless horizontal surface. So pulling the mass. So this is telling us we have mass, we attach with this one object to a force sensor. So we attach object to a force sensor. Simply we can imagine this one is the force sensor, and this is on frictionless horizontal surface. So we can determine in this case the inertial mass and measuring the acceleration. So in this case this is not depending on gravitational field, so this is not relying on gravitational field, so in this case what we will get, the mass we will get, that will be the inertial mass. So we can determine inertial mass using these two methods, C and D. So the answer for this question is C and D, inertial mass. Question 49 says the figure above shows a representation of a wave traveling in a uniform medium at a particular instant. Correct statements about the wave include which of the following? Select two answers. So in this case we have to select two answers which are correct about the given wave. If you look at this given wave, we can see the particles here. Particles are very close to each other, so we call this region is compression, And if you look at the next region, here we can see particles are far away from each other. We call this is rarefaction. So here again we have compression, here we have rarefaction, here we have compression. And this wave, a wave which consists of compressions and rarefaction, we call is a longitudinal wave. So this wave is longitudinal wave. So simply we can say this is longitudinal wave. So this is longitudinal wave, and the distance between two consecutive compressions or rarefactions is equal to one wavelength. So A is the distance between two consecutive compressions, so A is equal to lambda. Now if you look at given options, if you look at option A, it is given to us it is a longitudinal wave. Yes, this is correct. So this is longitudinal wave. Distance A is the wavelength. Yes, this is correct. The number of dots per unit length is the frequency. This is incorrect. Frequency is the number of cycles of a particle per unit time. Number of cycles per unit time of a particle means the number of cycles completed by a particle per unit time. That is the frequency. So this is incorrect. The largest distance between two successive dots is the amplitude. No, amplitude is the maximum displacement of a particle. Maximum is the maximum displacement of a particle from equilibrium. Maximum displacement of a particle, very important, of a particle from equilibrium. From equilibrium position, or we can say from rest. So D is also incorrect. This is the distance between two particles, largest, so this is also incorrect. So the answer for this question is A and B. Question 50 says a geologist is using a sensor to record waves in a layer of rock and is viewing them on a monitor screen. At one moment the monitor shows the signal above. If the signal is created by just two traveling waves, what can be concluded from the signal about the waves when they reach the sensor? Select two answers. So first of all, if we simply look at this given pattern, this pattern is representing beats. So these are beats, and for beats we need to understand they are produced when same type of waves traveling in the same direction, we can say same direction, slightly different frequencies, and different amplitudes. So I'm just writing it, different amplitude. When these waves they meet, they form beats. So if you understand these concepts, then simply we can figure out the answer. The waves have different frequencies. Yes, so this is correct. The waves have different amplitude. Yes, because amplitude is not zero. If they have the same amplitude, when they interfere destructively, resultant amplitude has to be zero. But in this case, resultant amplitude is not zero. It means they have different amplitude. So option A and B are correct. The waves are traveling in opposite directions. No. If these are beats, waves have to travel in the same direction. So this is incorrect. The waves are traveling at different speeds. No. Same type of wave in the same medium, they have the same speed. So this option is also incorrect. So the answer for this question is A and B. This question is simply about beats.